Wow, another large crate from Monport. Inside is the GA60, a powerful MOPA fiber laser capable of marking and carving metals, plastics, and more in a blink of an eye. What's a MOPA laser? And how did my new Sovol Zero 3D printer end up being essential to getting it running? Stick around to find out. I'll show you the complete Lightburn setup, which will help with similar lasers, and you'll see how 3D printing saved the day. Do you think you need a MOPA laser? I'll ask you again near the end of the video. In case you don't know me yet, I'm Gergo, and this is Gergo Print 3D, our YouTube channel where we take you along on our 3D printing and laser cutting adventures, exploring devices, making fun things with a good measure of tutorials, me being a teacher at heart. As always, curated, translation-ready subtitles and chapter markers make our videos easy to watch. I plan to make a few videos about this powerhouse. So we'll treat this as an introduction to MOPA lasers, taking you along on our unboxing experience and initial setup. I hope with the help of my video, it will go much smoother for you. We'll discover together what the GA60 from Monport is capable of. The crate weighed just 32 kilos this time, about 70 pounds, not impossible to lift alone. There was a little scare because the delivery person placed it on its side. How damaged was the inside? I couldn't drive out the insane number of screws quickly enough to check what was inside. The Onyx R55 from the same company had these easy to open tab and slot connectors. Here, they've used 25 screws. I counted. Anyway, the packaging was quite mixed in color and material, but did it protect this valuable device? First, I got to the accessories, and I was happy to see that this time they've included safety glasses. It's going to be a good spare because I'm planning to use the rated one I got from AliExpress. Don't buy just any safety glasses online. I've put links to this specific one from Hunst, a dedicated laser safety company, also selling on AliExpress. This pair was rated for OD6+ in the 1064 nanometer wavelength spectrum while having pretty good visible light transmittance. It fits over my prescription glasses and includes a retainer strap to keep it securely in place. Sorry, I got a bit distracted and you are still curious about how the machine survived the rough handling. We are almost there to see the potential damage, but first, let's take a peek inside this bag of accessories. So this is the user guide, which turned out to be mostly useless, and you'll see why. I know you don't care about the rest of the accessories, we'll get to them later. We want to see the machine. Okay, it's here. See the handwritten calibration information on the side of the arm and all the distortion data? We'll get back to that when we set up Lightburn in a minute. All great, but what's the best way to get this monster out of its box? I ended up following all the assembly steps in the manual. Don't worry, that's just 3 easy steps, more like 1. This thing comes 99.9% pre-assembled, but with the support column standing, I could get a much better grip and carried it into my office. I'm glad I double-checked because this nice 400mm metal ruler slipped under the packaging foam. It would have been a shame to accidentally throw this out. Oh, and by the way, the delivery guy placed the crate on this side. The support column wasn't even upside down. Thank God it made it to my desk without a scratch. Let's see if it turns on. But first, that USB port looks very sketchy, don't you think? The port is soldered to the controller board, deeper inside the device. The USB cable, being able to wiggle freely, will eventually rip the port off the controller board. It cannot stay like this. This is big trouble, but fairly easy to fix. Before continuing with the setup, I set out to design and 3D print this strain relief adapter for the Type B plug. It actually took less than 5 minutes to quickly measure the dimensions and design this tiny adapter that will fit around the USB plug and fill the rest of the hole in the back of the machine. Another 10 minutes and I had it printed out of G-Tech TPU. You won't believe the price of this filament. Okay, I'll show you. This is for 1 kilo. Even with shipping, it's amazing. Anyway, I really got distracted, but the link to this TPU is in the description as well. And yes, I printed it on my new Sovol Zero, the ideal 3D printer for small instant prints like this. And the Zero prints flexibles with zero problems. So a big no-no for the strain relief, but it ended up being an easy fix. There will be one more 3D printed improvement. I'll put both STLs in the description, or contact me. I can print one for you if you message me in the comments. Where were we? Oh, the rest of the ports back there. I see a 4-pin rotary attachment connector, and the unlabeled 2-pin connector is probably for a foot pedal. I will have to confirm that. The pedal is not included, but there's a button in the front. I'll explain that in the setup section. The power input includes a fuse, which I was happy to see. One more thing I just had to try before turning the device on. If you loosen the 4 screws around the base of the support column, you will be able to rotate the laser arm a full 360 degrees, providing a lot of freedom if you need to mark things that would not fit under the arm normally. Okay, sorry, I'm sure you want to see how this works. We are getting there, I promise. Check out the F-Theta lens. You'll see it's high quality with really good optical characteristics. This stock lens provides an ideal 175 by 175 work area, 320 millimeters away from the mark level. According to the table on the product page, upgrading to an f290 lens would still produce a very strong laser effect on a slightly bigger marking area, but the included lens is still optimal. We can also see the autofocus system and the 2 red dot lasers, which are used for manual focusing. I cover the different focusing methods after the setup. Continuing with the device tour, I'm pretty sure the gap here is by design and not the result of rough handling during shipping. My guess is that these leveling screws are to make the laser arm perfectly parallel to the work platform. It comes well calibrated out of the factory. Another tiny thing that I'm not particularly happy with is the lens cap. It not only feels cheap, but it doesn't fit the lens correctly. So another 3D print. But I won't bore you with the details this time. For this one, I still use my Zero and bright red Kingrun TPU. Hopefully that color will remind me to take it off and make it easier to find later. There is a single button up here and a few more on the main chassis below. We'll take a look at their functions after we turn the machine on. In fact, let's do that now. Make sure the button laser switch is not pressed, then flip the power switch at the back of the device to the 1 position. What a relief. My device turned on without issues, no smoke or fireworks. That delivery mishap might not have caused any problems. I can hear a very slight buzzing sound of the galvo, but no fans. If you hear the fans, release the laser switch on the front. We'll get back to it later. The computer makes the USB connection sound, but the Windows drivers are not automatically configured. The included printed manual and even the PDF on the USB drive had outdated information. Adding the JCZ fiber controller in Lightburn did not work. I discovered my upgraded device has the new BSL controller, not the older JPT. I confirmed this by spotting IFPN60 GME through the venting grills in the back. The updated steps were in the online version of the manual on Monport's website, so if you have the newer model with the BSL controller, these are the Lightburn setup steps for Windows. Step 1, preparations. Take the BSL app simple archive on your USB drive and extract its contents to a subfolder. We'll need the config and driver folders from there. Connect USB and power on your GA60. Step 2, install driver. In Windows Device Manager, right-click on SCA Laser under Other Devices, which is missing its driver. Select Update Driver, click Browse My Computer, and navigate to the recently extracted driver subfolder on your USB drive. Select x64. If successful, this will install the Cypress FX2LP sample device. It seems they haven't bothered renaming the sample driver to their device. Step 3, Install Galvo drivers for Lightburn. Lightburn requires a specific driver for these lasers. If you've never used a Galvo laser with Lightburn before, you need to enable the EasyCat2 driver during installation. If you already have Lightburn installed without this driver, you need to reinstall it. Don't worry, this won't affect your existing settings. Step 4, we add the Monport GA60 to Lightburn. For this, we click on Devices, Create Manually. From the controller list, select BSL Fiber. In the next step, we need to import the SCA CAD config. Again, from the recently extracted folder on the USB drive, choose the file bslcad.cfg. In the final step, we can provide a proper name and the dimensions with the stock lens as 175 by 175 millimeters. You should then see the status ready in the laser tab of Lightburn. So far, so good. We need a few more settings though in Lightburn's device settings under ports and laser. Because this is a MOPA laser, set the laser type to IPG/LPM. MOPA lasers offer a wider frequency range, 1 through 3000 kHz, and adjustable pulse width. For this, enable the Q-pulse setting. This allows for color marking on steel and expands the material options compared to non-MOPA lasers with fixed pulse width and lower, narrower frequency range. We'll explore these capabilities further in future videos, so subscribe. Next, we need to set up our ports. For the red dot preview to show up, we'll need to set it on port 0 and set it to always on. Now there's a button on the front labeled foot switch. First, press the button and you'll see port 1 turn off in Lightburn. This means we can assign port 1 to control a function. For example, we can set it to start marking. Crucially, you need to set it to active low. Also make sure it's set to require a full press and release, i.e. it's pulse triggered. This means you have to press and release the button for the marking to begin. Now go to the Galvo settings page and set Galvo 2 as the x-axis. Next, copy the red dot scale and offset values from the calibration plate on the side of the device, but be careful. On my machine, the Galvo 1 and Galvo 2 data were swapped, resulting in distorted lines. I discovered that since Galvo 2 is the x-axis, you need to enter its data for Galvo 1. This corrected the test pattern for me. Before making our first test markings, let's spend a few moments talking about the rest of the buttons. With the laser switch off, the power button in the back only activates the Galvo system. Those little mirrors which move the light around, and the red dot lasers, but not the main laser source. The former lets you preview your markings and focus manually. To do this, turn on the focus assist beams button on the front of the laser arm and rotate the knob on the support column until the two red dots converge into a single point. We can go ahead and actually draw something in Lightburn. We'll engrave this on one of the included painted cards. Set the layer parameters accordingly: 5000 mm/second speed, 50% power, 0.04 millimeter interval, 100 nanoseconds pulse, and 400 kHz frequency should be sufficient, though I'm not an expert. Now, let's click the frame button, and you should see a flickering preview of your design using the low power red laser. Try the 3 preview methods. You can even press the start button. As long as the laser switch is in the off position, it will only simulate the marking process using the weaker red laser. Okay, close the preview dialog and let's put on our safety glasses. I recommend wearing them as soon as you connect the device to power, but surely before activating this laser switch. When you engage the laser switch, the cooling fans start and the autofocus system activates. The focus motors engage. We no longer can turn the knob on the top. Instead, we can use the up and down buttons or place our workpiece in the autofocus zone and press the focus button to let the machine focus automatically. Pressing the frame button in Lightburn will still show you the red dot preview, but with the laser switch enabled, pressing start or the foot switch on the device will activate the main laser. Now, before you do, make sure you have good ventilation. At least open your windows, but a fume extractor or an inline fan like the one I am using to vent outside is highly recommended. I received this with my Monport CO2 laser, but you can get similar kits online for a few dollars. Links in the description. In a later video, I actually plan to build an enclosure. I already have the materials delivered. So, after we've ensured proper ventilation, now we can finally press that start button. Don't blink, because you'll miss it. Here, let me play it again. This is the power of galvos. The mirrors move so quickly, and 60 watt is such high power that something like this can be engraved in less than a second. Just imagine marking all your USB chargers and cables with your name like I did, so I don't mix them up with friends on trips. It takes a few seconds to line them up with the preview, and less than a second to put my logo on them. I was able to mark plastics and various metals alike. Marking this knife took a bit longer, but with an outdoor enthusiast friend of mine, we were able to put his logo on the D2 hardness steel blade of his pocket knife. We even marked the titanium handle with his Instagram handle. If you are into knives, multi-tools and flashlights, feel free to check out his account on Instagram. I have the feeling we will mark a few more things from his collection. And you know I cannot leave out my little nephew. We ordered these high quality blank belts, AliExpress link below, and engraved the logo of his favorite show, One Piece, on it. This was one of the very first things we did, and it turned out so perfect. I ended up putting the same logo on my belt buckle as well. I have a pile of other engravable blanks from Creator Rally and AliExpress, wallets, money clips, lighters, bottle openers, compasses, or basically anything made of plastic or metal can be a basis for a small business. You only need to invest in a single machine, and you or a family member can start working from home. We've only touched the surface, literally. There is so much more, so much I want to experiment with and work out for you. 3D engraving coins, color marking stainless steel business cards, creating a metal card game set, or decorating 3D printed items. So now, do you need a MOPA laser? I'm sure you do. You just need to find a way to get one. The upgraded GA60 MOPA from Monport costs several $1,000s less than competitors or even its regular price, and offers exceptional mechanical stability, astonishing galvo speeds, optimal work area and laser power, and an impressive feature set including the rotating arm, autofocus, full Lightburn compatibility, and multiple levels of safety. If you do decide to get a Monport device, please use my affiliate links in the description so we can get a little kickback without it costing any extra for you. Better yet, use my coupon code GERGO10 to save even more, be it on their US or EU site. If you do, please don't use browser plugins like Honey, because they steal commissions from creators like us. And don't worry, I don't switch completely to lasers. My main focus is still on 3D printing. You saw how I couldn't stay away from using my 3D printers even in this video. In fact, if that little 3D printer piqued your interest, I had the privilege of beta testing the Sovol Zero for months, and I tell you all about it, and it hasn't even been released yet. Be sure to check it out in this video. We already have another laser from Monport. Do you know how a CO2 laser works? I show you in this other video, because, wait for it, we not only go print 3D, but do all kinds of laser stuff too. Thanks for watching another Gergo Print 3D video to its very end.